My name is Eric Johnson. I'm a Senior Developer Advocate for Serverless at AWS. This video is the fourth of a series designed to help you build serverless applications using the AWS Serverless Application Model, also known as AWS SAM. In this video, I demonstrate developing serverless applications locally using the SAM local command. Before we walk through this command, it is essential to understand how AWS Cloud Services invoke the AWS Lambda function. AWS services invoke a Lambda function by calling the Lambda Service API. Services like API Gateway make a synchronous call and wait for a response. Other services like Amazon S3 make asynchronous requests and do not wait for a response. These requests are placed in an Amazon SQS queue to be processed by the Lambda service. SAM Local provides a set of subcommands that allow you to emulate these options and test your code's validity before it ever leaves your machine. To best help you understand how they work, I'll walk through each option and explain the benefits. This first command, SAM Local Invoke, emulates calling the service directly. Let's look at this simple application to demonstrate. In this example template, I have a Lambda function that does not have an event source configured. In the function's application code, I write hello console to the console and output the hello world message. To invoke the Lambda function locally, I run SAM local invoke and my function's logical name, which in this case is hello world function. If there's only one function in the template, you do not have to include the function name, but it is a good practice. AWS SAM first verifies if the appropriate container is available to invoke the Lambda. If it is not locally present, AWS SAM downloads the container and invokes the Lambda function within it. In the terminal, the Lambda function has emitted the log hello console and returned the message hello world. The invoke function allows you to simulate a Lambda function invocation from an AWS service without emulating that service locally. For example, I have a Lambda function that gets invoked from an Amazon SQS queue. The function loops through incoming records and logs them to the console before exiting. To test, I need to provide an event. I have a file called events.json with a mock event containing two records. Rerunning the SAM local invoke hello world function command, I now add the events flag and pass the events file's path. AWS SAM passes the JSON data in the file to the Lambda function's incoming event parameter on invocation. During the invocation, the Lambda function logs both records to the console and then exits. You will note that I casually said to create an events.json file with an example of an SQS receive message event in it. But you may not know the structure of an SQS receive message event. Not to worry. AWS SAM has a utility to help. In the terminal, I run the command SAM local generate event. AWS SAM lists all the available event types supported by SAM. SQS is one of the event types listed. To get more information, I run this command AWS SAM local generate events SQS. AWS SAM lists the help menu for SQS and lists receive message as the only option. Now, running the command SAM local generate event SQS receive message, AWS SAM returns a JSON object with the proper event structure. I then rerun the command but output to a file. I now have an event to test the Lambda function. I encourage you to explore the different event and event options that AWS SAM generates. In addition to incoming events, AWS SAM can also test Lambda functions that interact with AWS services during invocation. Sticking with my SQS example, I add an Amazon DynamoDB table and update the Lambda function to write to the table instead of the console. Additionally, I will add a second Lambda function to read data from the DynamoDB table. Before I can test the code, there are a few steps I need to take. First, I need to deploy the stack, which I have already done. For my local Lambda functions to interact with a DynamoDB table in the AWS cloud, the table needs to exist. Second, I need to tell AWS SAM the DynamoDB table's name using a local variables file. A local variables file maps any environment variable declared on the Lambda function to existing cloud resources when using AWS SAM local. In this example, I declare an environment variable called table name. I place it in the global section to apply to both Lambda functions. I then create a local file with an entry for each function that maps the table name to the physical name of the DynamoDB table. I name the file locals.json, but you can call it anything you'd like. For more information on the local variables file, go to s12d.com/local-variables. The last step before testing is to use the SAM build command to prepare the artifacts. Until now, for simplicity, I have not built the application before I test it. I could do this because I am not using any dependencies in the application, and Node.js does not need compiling. I run the SAM build command. Once completed, I run the SAM local invoke command with the new env-vars flag to pass in the local environments file. AWS SAM invokes the Lambda function locally using the event.json file as an event. The code loops through SQS messages and writes the messages ID and body to the DynamoDB table, which is in the AWS cloud. I then test the second Lambda function with a similar command without the event. The results display the two messages that the local Lambda function wrote to the DynamoDB table. On a side note, I recommend installing something like the JQ library or JMES path for formatting JSON in the console. With JQ installed, I rerun the command and pipe it to JQ, making the results easier to read. A typical pattern used in serverless is to build an API. With that in mind, AWS SAM Local also provides a start API command. This wraps the invoke function with an Amazon API gateway emulator that supports REST and HTTP APIs. While it is not a full API gateway implementation, Start API exposes a persistent local endpoint for testing. When the endpoint is called, AWS SAM invokes the local Lambda function as if it were coming from an API gateway endpoint. This functionality helps test local clients against a local background. Returning to my SQS DynamoDB example, I add an HTTP API's event source to the Lambda function that reads the cloud-based DynamoDB table. I then run the start API command with the additional environment vars flag. AWS SAM then creates an endpoint for each Lambda function with a REST or HTTP event source configured. In this case, it is just my read Lambda function. I then test the endpoint using curl in a separate terminal. Each time I invoke the Lambda function, AWS SAM starts the container, processes the response, and terminates the container. This process is good for testing once or twice, but to test repeatedly, add the warm containers flag when running Start API. The warm container flag tells AWS SAM to keep a warm container for each endpoint needed. When using warm containers, you instruct AWS SAM to be eager and load all containers at startup, or be lazy and only load them as needed. In both choices, the containers then stay persistent for subsequent requests. I rerun the start API command with warm containers, and you can see that the endpoint is much more responsive. Okay, let's take a look at the final command for testing Lambda functions locally, the SAM local start Lambda command. Like start API, this command wraps the invoke function. However, instead of wrapping it in an API gateway emulator, the start Lambda function emulates the Lambda service itself. When running the start Lambda command, AWS SAM creates a local endpoint that directly invokes the Lambda function when called. This command enables local testing of Lambda functions with the AWS CLI and AWS SDKs. In this example, I use the AWS CLI to test the Lambda function. I set the endpoint to the local endpoint exposed from the start Lambda command and pass the function's logical name. I also give it an output file of out.json. The Lambda service responds with the status code of 200, and the Lambda function's response goes in the output file. With these three commands, AWS SAM gives you the ability to produce many iterations of code before it ever leaves your desktop. We built AWS SAM to help you iterate quickly without having to bring the cloud to your desktop. The best practice is to test against real services whenever possible, and that is the approach I have shown here. One fundamental reason for this approach is security. When running commands, AWS SAM uses the credentials from your local profile. Most likely, your profile is much broader in permissions than the Lambda function will have when deployed. For this reason, it is important to test the Lambda function in an AWS cloud environment early and often. This session has been an overview of the AWS SAM CLI SAM local command. I covered locally invoking a Lambda function directly, through an API gateway, and with AWS CLI or SDKs. I also talked about the generate event command to create mock events for testing. And we spent time understanding some of the flags to modify how SAM local commands work. In the next session of this series, I cover the AWS SAM deploy command. I encourage you to watch. For more content like this, visit serverlessland.com. Until then, thank you for watching. My name is Eric Johnson, and you can find me on Twitter at EDJGeek. Have a great day, and remember, serverless for everyone.